Okay, welcome everyone. I'll just wait a little longer for a few more people to join, and then we'll start our webinar. Okay, so welcome to the webinar on our recent changes to the insulation and insulation requirements for compliance with the building code in houses and other buildings. My name is Richard Armand, and I'll be hosting the webinar today. I'll be speaking to one of our technical experts who's been working a lot on these changes and previous changes. I'm like I say, I'm Richard Armand. I'm a senior architect here at MB. First up, apologies for a couple of weeks ago. We had a few IT issues with our initial set of webinars or virtual town halls. I'm not sure what happened. It's something to do with, well, I've heard it's something to do with security certificates and lots of people. Not sure. So yeah, apologies for that, and I appreciate everyone coming back over the last couple of weeks to join us. So today we're going to briefly talk about some of the background on the insulation requirements of the building code. Then we'll be talking about what has changed and when the designers have to implement those changes. We will try and keep a lot of time for questions at the end. We did this webinar last week, and we've got some, there's some common threads for questions. So yeah, we only have so much time, so we'll try and we'll crack into it as soon as we can. So today, our technical expert talking to us has been, he's been championing H1 for a long time. He previously worked at ECA, and he's been working at MB for about 7 years. Like I say, he's been championing H1 energy efficiency clause and insulation for a long time. In fact, some people call him the Lisa Carrington of energy efficiency. His name is Christian Herning. He's a senior building scientist based in Wellington, in our Wellington office, and he's originally from Germany. I like to call him the building scientist from Saxony, Christian Herning. Welcome.
Everyone.
So start off from the beginning. Can you tell us a bit about the background of the insulation requirements within the building code, within the New Zealand building code?
Sure. So the Building Act obviously requires that all building work complies with the building code, and in the building code there's clause H1 that specifies requirements for the energy efficiency of buildings, and one of these requirements you see here on your screen, which is about the building envelope needing to provide adequate thermal resistance. Now, in plain English, adequate thermal resistance simply means that there needs to be sufficient insulation in the roof, walls, windows, floor of a building. And as you can see, the building code doesn't actually specify how much insulation is required. It just says adequate thermal resistance. So instead, MB publishes documents that are called acceptable solutions and verification methods. And these are the documents that contain compliance methods with technical requirements for demonstrating that the building meets those minimum building code requirements, such as adequate thermal resistance. And so the changes we're talking about today are updates to 4 acceptable solutions and verification methods for building code clause H1 energy efficiency. And these are H1 AS1 and H1 VM1 6th editions. And these are the 2 documents for the energy efficiency for all housing and also other buildings that are up to 300 square meters. So just to clarify, housing of any size, even huge apartment buildings, fit into H1, AS1 and VM1. But buildings that are not housing, there you need to check, is it up to 300 square meters, then it fits into H1, AS1 or VM1. Otherwise, they fit into H1, AS2 or H1 VM2, and these are the documents for the energy efficiency of buildings greater than 300 square meters, and that's for buildings that are not housing. And so we now have the second editions of H1, AS2, and VM2. So collectively, these 4 documents were published on the 27th of November.
So there's been a lot of changes lately. Can you explain how these changes came about? Why these changes have come about?
Yeah, so as you alluded to in your intro, Richard, back in 2021, MB did an earlier update of these H1 acceptable solutions and verification methods. And at the time, the objective was to make new buildings healthier and more energy efficient. So we consulted back then, and the sector and the public provided MB with overwhelming support, actually, to lift the minimum insulation requirements. And so that was done. And these increased H1 insulation requirements were then phased in through to the end of 2023. But then in 2024, some people started raising concerns about the 2021 insulation changes. Those concerns were primarily related to the upfront cost impacts, but questions were also raised about whether the additional insulation would be making new houses too hot or create moisture problems. And so we investigated these concerns. We talked to some key people in the construction sector to hear about their practical experience with the new H1 settings. And we also sought independent cost estimates, and we commissioned brands to complete an updated cost benefit analysis and look into these overheating and moisture concerns. So what came out of that was both the discussions with the sector as well as the independent cost estimates confirmed that some of the cost increases that people attributed to the increased insulation requirements were higher than they actually were, or the claims were higher than what was actually. In fact, the cost impacts were very much in line with what we estimated back in 2021, and not as big as claimed by some. When it came to overheating, what a lot of designers told us, what Brands' modeling confirmed was that it's a bit more complicated than attributing it to insulation. Primarily, whether a house or building is at risk of overheating, primarily that relates to the design of a building, specifically about how much of the sun's heat can enter the building through glazing. And that obviously depends on the orientation of the building, the size of the glazing, whether the glazing is shaded, the type of glass that is used. So a lot of these things. So how much heat can get in? And then the other factor is obviously how much of the heat can get out again. So how well is a building designed so that you can get good ventilation or cross ventilation to just sort of get rid of that hot, stuffy air at the end of the day. And the insulation was just one factor that in some situation could make a building accumulate more heat when it starts overheating, but insulation obviously is also good at keeping heat out. For example, if the sun beats on your roof and the roof surface heats up, insulation actually helps keep that heat out for longer. So anyway, based on all the feedback we got and the new intel we got, we put together some proposals for changing the H1 acceptable solution verification methods and consulted on those in late 2024, early 2025, so a bit over a year ago.
Oh, sorry. I was going to say, so we consulted on them. What did people say? So what was the feedback we got when we had this consultation? And just a quick aside here, I just want to reassure people that every response we get to a consultation gets read by a human, by a technical expert, and assessed and kind of thrown in the mix. So what did people say from the consultation, Christian?
Good question. Maybe first I'll talk about what our objectives were, and then I'll go into what we heard. So the objectives this time around with the update that we've just done was, first of all, to better balance the upfront building costs and the longer term benefits. Secondly, to make the documents clearer and improve the consistency and certainty of compliance, so that there's less risk of misunderstandings and RFIs. And thirdly, after the 2021 update clearly had the intention to lift insulation levels, this time around, the objective was to maintain that required level of energy efficiency. So not to reduce it, but also not to further lift it, to sort of roughly keep it the same. And so in terms of the feedback that we got, as Richard said, we're very grateful for all of those who took the time and wrote a submission. So for any of you on the call who were involved in a submission to that consultation, big thank you. That really helps us, that feedback, in shaping those changes that we've just made. We've received 256 submissions, and we obviously heard a wide range of views. So that's, it's people along a broad spectrum that, some are really concerned about the cost and say things have already gone too far. And there's others that say the current settings are way too low and need to be lifted further, and anything in between. And so obviously we're unable to please everyone, but I think overall, generally speaking, we received good support to proceed with pretty much all of the consultation proposals that we had, but with some tweaks to some. And in addition to that, in the consultation feedback, we also received a number of suggestions for additional changes to H1 documents. And so where these were consistent with these objectives that you still see on your screen, and where the impacts were, reasonably well understood and not too major, we were able to incorporate these suggestions right away in this update just done. And there were other suggestions that we couldn't implement right away because we would want to do a little bit more analysis and consultation. So thank you for those suggestions also. We have a list of those, and so we'll keep them in mind for next time.
That's a really good point. I like that point about maintain the required level of energy efficiency, because I remember some of the comments last time we were saying, hey, are we winding it back? And we're not winding it back, we're just sharpening the tools, so to speak, aren't we? So with that, let's start with some of these changes for insulation and housing and small building. What can you tell us about these?
So, as you said, not winding things back. I think the other thing to probably keep in mind about H1 is a clause in the law that specifies minimum legal requirements. And we're talking minimum requirements. So there is room to exceed minimum requirements. So just building to just comply doesn't guarantee that it's going to be a great super energy efficient building. Just complying with H1 means just complying, just meeting the minimum requirements. And I think that's something I think we all know, but it's sometimes it's worth just reiterating that.
Mm-hmm.
So housing in small buildings, H1 AS1, H1 VM1 are the two documents. The biggest change that was already announced, so shouldn't come to as a surprise to anyone, was that the schedule method has been removed, and that now leaves just the calculation method in H1 AS1 and just the modeling method in H1 VM1. Now, the removal of the schedule method was a move that was backed by the majority of people and organizations who responded to the public consultation. And whilst the reason is that whilst the schedule method was in the past obviously quite popular because it was easiest to use, that ease of use came at the expense of the settings being a bit more conservative and more costly. And that was also confirmed when we got these cost estimates and brands did their cost-benefit analysis, that the calculation and modeling method, because they enable customization of the insulation levels around the different parts of your building's thermal envelope, they enable you as a designer to sharpen your pencil a little bit and cost optimize compared to the schedule method that is now being removed. And in the consultation, we also heard that many designers had already started adopting the calculation method more instead of the schedule method.
Right. And so you said that the schedule method was the easiest to use, and it's now being removed. How difficult are the calculation and the modeling methods, which we will be needing to use now?
Yeah. So the modeling method requires specialist modeling software skills, and these can be acquired, but I think I would expect that not all designers may want to go down that modeling route right away for all your projects. But in contrast, the calculation method has been made much more accessible and easier to use thanks to a range of user-friendly online tools that implement the equations from H1 AS1. So the calculation method is described in lots of words and equations in H1 AS1, but when you use these tools, it all becomes much easier because they just basically do all the calcs in the background for you. And so there's a range of tools out there that you can use. There are some commercial ones that charge you a little fee for their use, and you might want to explore those. There are also free tools like the Green Building Council's online tool. Here's a screenshot of that. So all it basically requires you to do is to specify where you want to build. So in which council area, that then automatically assigns the relevant H1 climate zone. Then you need to enter the different building elements that make up your thermal envelope and tell the tool their areas and their R values, depending on how you want to construct them. And the tool does the rest for you. It basically does all the calcs and then tells you whether you comply or not. And if you don't comply, well, then that means you need to make some tweaks either to your window areas or to your R values, put more insulation in. And so that's sort of a quick glance at the Green Building Council's tool that you can access for free on their website. And brands have created a spreadsheet-based, Excel-based tool. And both these tools are updated to the new H1 documents. So they've already adopted the changes. And basically, the difference with the brands tool is it looks a little bit different. It basically asks for the same inputs, and you download it and open it in Excel instead of using it straight on your internet. Yeah.
Okay, so I've also heard that you've made some changes to the calculation method. What are they?
Yeah, so great question. So sorry, I just have some screen navigation challenges.
Take your time.
So with the H1 AS1 calculation method, the main way compliance is tested is that there is a calculation happening that works out the heat loss of your proposed building's thermal envelope based on the R values and areas of your roof, your walls, your windows, your floor. And then there is in parallel, there's another calculation happening for something that's called the reference building, which is sort of a theoretical kind of mirror image of your proposed building, but with some tweaks to its window areas and some tweaks to the R values. And your proposed building must not have a heat loss that's greater than that of the reference building. Now that happens in the background of these tools, but there are some other requirements. So the calculation method gives you a lot of flexibility about how much or how little insulation you want to put into the various bits of your thermal envelope. But with the H1 AS1 calculation method, there are some backstop minimum R values still for the roof, the walls, and the floor that you must meet or exceed. Yeah, so that's sort of just a limit to how low you can go for the roof, the walls, and the floor. And that's already been in place with the previous editions of the H1 calculation method. And we've made some tweaks to those minimum R values. So the key changes are that for the roof, we've reduced the minimum R value from R3.3 to R2.6 across all zones. And that is just to make it a bit easier and less costly for those buildings where there might be that the space for insulation in the roof might be very tight. Like if you have a low pitched roof in the, in that little triangle at the roof edge, it can be challenging to put thick insulation in. And so being able to reduce it there to R2.6 can avoid costly things like raised heels. And so that's the roof. And the other key change is that we've removed the minimum R value for slab on ground floors. Now that was a bit of a controversial thing in the consultation feedback because, well, if you think about you're building a house for decades, that will be around for decades, and things will be changed over as during the life of the building. But one thing is for sure is once the slab's poured, you're not going to be able to put insulation under the slab. And so there were people concerned about that. Whereas other people said, yeah, the slab insulation is such a headache and quite costly. Now, let me explain to you what the main reason was why we proposed removing the slab on ground floor minimum R value. The previous minimum R value was only, depended on the climate zone, but it ranged from about R0.75 to R0.R5. So it was actually quite low. That minimum R value would, if it is the slab for an entire house with lots of spaces, living rooms, bedrooms, kitchens and stuff directly over the slab, that minimum R value that was there in the previous edition would not have forced anyone to put insulation around the slab. But even though it was so small, it could make things quite tricky where you only had a very small slab area that was part of a conditioned space. And an example would be, imagine a 2-story house, and on the ground floor, it's pretty much just a double garage, and all the living spaces are on the first floor. But there might be an open stairwell going down towards the garage. And so the only conditioned part of the slab might be the stair landing. So we're talking about a couple of square meters. And because the R value of a slab not just depends on the insulation of it, but also on its size and shape. So we're calling this the area to perimeter ratio. A little area like a stair landing is very small, has a very low area to perimeter ratio, and therefore, even if you insulate it, generally a very small R value, very low R value. And so that with the previous minimum R values, despite them being quite low, could have made things quite complicated and costly to try and super insulate, well, not super insulate, but to insulate such a small isolated area. And the feedback we got prior to the consultation was that it was more trouble than it was worth. And as I said before, those minimum R values as they were, they wouldn't have made anyone insulate an entire big slab area anyway. So this is now removed. So if you have a stair landing like that or some other tiny area, that complication is removed. If you do have a slab under an entire house, think about insulating the slab anyway, even though H1 might not force you to do it, because, you know, I think the people that are concerned about not being able to retrofit slab insulation for the next 50, 100 years that building might be around, I think they've got a point.
Mm-hmm. And these are the minimum requirements. I'll get it out eventually. Yeah. These are the minimum requirements. You don't get penalised if you go above them. So thanks you for that.
One thing that I forgot to say is that despite those changes to the minimum RVUs for that calculation method, the overall required level of thermal performance of the calculation method remains unchanged. Remember what I said at the beginning of, for that slide. The primary test is, does the heat loss of your proposed building, is it not worse than that of the reference building? Those settings haven't really changed. Mm-hmm. It's just those minimum RVUs that we've tweaked. So there's now more flexibility. But if you're taking advantage of those minimum RVU changes, you will need to compensate for that somewhere else in the lot. So if you decide to reduce your roof R value to 2.6, or reduce your floor slab R value somewhere else in the thermal envelope, you will need to make up for that.
You'll be making it up. That makes good sense. So overall stringency of the calculation method is kept the same, but some of the backstop minimum R values have been relaxed, and particularly for roofs and for slabs on slabs on ground. What about changes for underfloor heating in bathrooms? Because that was quite a big one as well, wasn't it?
Yeah. Another point. So the minimum R values that I just talked about, they were specifically for the H1 AS1 calculation method. They don't appear in any of the other compliance methods. But if you want to put heated ceilings, heated walls, or heated floors, and most likely it would be underfloor heating into a building, and where those elements form part of the thermal envelope, then you need to meet certain minimum R values that are, a bit higher than what the other minimum R values are, and you see them in the table on your screen here. And the reason is simply, if you heat up, say, a floor for the purpose of heating the rooms above, that floor gets quite warm. There's a much greater temperature difference than if you didn't have the heating straight in the floor. And to make sure that you don't have excessive heat loss and that actually the heating system is effective and the heat goes into the rooms rather than to the outside and the ground underneath, it's a good idea to put some good insulation there, and that's what these minimum R values aim to achieve. Now, that makes a lot of sense when you have, say, underfloor heating throughout a house. But sometimes people only put a little bit of floor heating, say, into the bathroom for like a square meter or two. And oftentimes that's under tile heating. And in such situations, the amount of heat that goes into the floor is quite limited. People might not even use it all the time. They might only use it intermittently. And to achieve those minimum RVs in the table would have been, or was, quite complicated and costly. And so we've added a new exemption in. So if you just want to have heated elements like underfloor or under tile heating in rooms that contain a shower, a bath, or a toilet, then you're basically exempt from having to meet those minimum R values in that table here. If you also want to put underfloor heating into other spaces, then the entire house, like all the elements that have that heating built in, will need to meet those minimum R values.
Okay, there's actually someone's asked in the comments just on the side, has anyone ever seen a heated ceiling? And yes, I have in Scotland, but not in New Zealand. So there we go. So are there any changes to the modelling method for housing and small buildings?
Yes, we've made some updates there too, to clarify things, to update some of the key assumptions that go into the modeling method, and that really is just to improve the accuracy of the modeling and to make things clearer so there is less, there's better consistency and clarity also between building consent applicants and building consent authorities. So without going into all the details, there have been changes about what weather files you're meant to use when you do the modeling. We've clarified what solar heat gain coefficient should be used for the glazing in that theoretical reference building. Doesn't mean that it dictates what glass you can put into your proposed building. This is just that benchmark reference building, how that should be modeled. We've made some changes to the default modeling assumptions for internal gains that the modeling software assumes in terms of the heat released from appliances that are in the house and from bodies, like from people. Yeah, so these are the main things. I guess one new requirement to highlight also is that where a modeler decides to deviate from some of the default assumptions provided in H1 VM1, they will now need to document those deviations clearly and also justify them. And that again is just so that a building consent officer can look at this documentation and understand what's been done and why to, again, improve that transparency and reduce the risk of, RFIs going back and forth. For those interested, all the details are in H1 VM1, so take the time to have a good read of it yourself. And otherwise, I think we'll leave it there for now.
So in recent years, we've seen more multi-unit housing being built. With those, do you apply the calculation or the modelling method for each unit individually or just as one large building?
Yeah, great question. So to date, with the previous documents, the answer would have been one thermal envelope per building. But now, with these updated documents, we've added a new option where you can either divide the building, where you can also now divide the building into multiple thermal envelopes. And that's specifically where you either have multiple housing units, like an apartment building or townhouses, or where you have multiple classified uses. So that could, for example, be in apartment buildings with, housing on the upper floors and say shops on the first floor, on the ground floor, and where you could divide between the commercial shop area and the residential housing part of the building. So if you want to treat a building as having multiple thermal envelopes, you can then basically use either the calculation or modeling method for each of the thermal envelopes or the building parts separately as if they were separate buildings. And I'm going to walk you through a little example that I've got here. So let's just take this example of a row of townhouses, 3 in this example. The first option is that you treat this whole row of townhouses as one thermal envelope. So that's shown with the orange line here. Basically orange, the thermal envelope goes around the entire row of the townhouses. So that's the first floor. That's the ground floor. Now on the ground floor, we've got garages here. Garages, typically we want to see outside the thermal envelope because they're not heated or cooled. You've got quite a few drafts coming through the garage door. Typically, it's not well insulated. So you want to leave the thermal envelope so in a way so that the walls between the house and the garage, those internal walls, are insulated and form the thermal envelope, and you leave the garage outside the thermal envelope. Now, obviously, this is the ground floor. That's the first floor. this one above. So you see there's a bedroom here. And so the ceiling between the garage and the bedrooms would also obviously need to be insulated and form part of the thermal envelope. Yeah, and so what you see here again, that's the option 1 with just a single thermal envelope. And now you can also decide, okay, I want to treat each unit individually. And that might make sense when you have, say, a subdivision where you have certain standard townhouse units that you want to string together in different sequences, different orders throughout the subdivision, and you just want to sort of say, okay, got my 3 standard types, and I just want to demonstrate that each of those 3 types complies in one go, like once for each, rather than having to go through row by row by row where they are all just sort of matched together differently. So you see here, each unit has its own thermal envelope. What I want to highlight also is, so here you've got intertenancy walls. On each side of the intertenancy walls, there's conditioned spaces where the neighbors basically have their living spaces that they heat and cool. And because there are conditioned spaces on either side of those intertenancy walls, they do not form part of the thermal envelope. So what that means is when you, for example, use the calculation method, you would not include these intertenancy walls in the areas that you put into your tool or into your equation. You would only focus on those walls, floors and ceilings that are genuinely part of the thermal envelope. So that's elements that separate conditioned spaces from the outdoors, or conditioned spaces from unconditioned spaces like the garage here. Yeah.
Mm-hmm.
And the other thing to be mindful of is in the calculation method, obviously gives you lots of flexibility, but there is a limit to how much glazing you can have. And that limit is 40%. So your wall glazing area must not be more than 40% of the gross wall area. And the gross wall area is basically the area of the walls that form part of the thermal envelope. And so if you look at that middle unit here, you see those yellow walls that form part of the thermal envelope are, just the front and back walls. And so 40% of that is less than if you look at the end units that obviously also have those side walls here, the end. And so this is just something you need to be careful with, that you're not exceeding the 40%, especially when you treat these units individually. If you run into problems there, then obviously you could either adjust the glazing area so that you're within the 40%, or you could then look at the option of treating the entire row as one thermal envelope where it all averages out a little bit more. Or you could decide to model the building, and then you don't have that 40% glazing area limit. I think that's all I wanted to talk about on that point. Yep.
Great. Just before we move on, I'm just going to address one of the questions because it could be misinterpreted. The slab edge insulation, there was Brand's research indicating that the slab edge insulation did make the wall floor junction perform 30 to 40% better, not the actual wall insulation. So that was Brand's research, SR352. So there is just a question in there saying actually it makes your wall perform better. It's just a junction between the slab edge and the bottom plate. So we'll come back to that question later. I just wanted to before it gets too far embedded in people's minds. So now I also remember talking about bottom plates, that the consultation included a proposal related to how much framing goes into walls. Are we trying to change how people build?
trying not, well, at this point, we're not forcing people to change how people build, but we want the H1 compliance calculations to be a bit more honest and accurate.
Right.
And so we've made changes in that respect. So we've made some changes to how designers need to determine the R value of the framed wall. And so we want to improve the accuracy and consistency in the H1 calculations and also create a more level playing field between buildings that have framed walls and buildings that don't have framing in the walls. And so the changes don't require walls or buildings to be constructed any differently. They also don't create any additional work for designers and building consent authorities. But the problem that we've had was that obviously many buildings have walls where the insulation is installed between either timber or steel framing, and heat finds it easier to escape through the framing than through the insulation. It's called thermal bridging, and the more framing a wall has, the worse is its thermal performance, or its R value is lower. And when working out what R value your proposed wall has, as a designer, you need to consider that thermal bridging from the framing. And so research by Beacon Pathway and also more recent data from Placemakers, framing manufacturing division, has shown that designers commonly vastly underestimated how much framing actually went into the walls versus what is actually being built. And this means that the R values achieved by framed walls were commonly grossly overestimated.
Okay. So how have we addressed that?
Yeah, so with the updated H1 acceptable solutions and verification methods, designer now must assume when you work out your R value of your proposed framed walls, you now must assume that there's at least 38% of framing in that wall area. So a framing fraction of at least 38%. Unless you can demonstrate that a lower wall framing fraction is appropriate for the building. So to start with, we expect that many designers will simply use the default value of 38%. And so if you do a calculation of your R value to enter as 4214, or if you use one of those tools like the Brand's House Insulation Guide, then you need to make sure that you assume at least 38% of the wall being made up of framing. And because we wanted to avoid imposing additional costs, we've also adjusted the wall R value in the theoretical reference building. So there, despite you needing to assume a higher framing percentage in your R value calculation, we've basically made other adjustments to make sure that the H1 doesn't become more stringent because of that at this point. And now, if as a designer you do want to go to some effort and actively reduce the amount of framing in your walls, and there are ways of doing that, like not using Dwings or Knox, for example, then you can be rewarded for that. If you can document that your actual wall framing fraction is less than the 38%. And that could either be by showing a detailed framing design and doing a calculation based off that, or there's also at least one framing manufacturer that can offer you the service of producing a certificate where they basically run your design through their framing software as if they were to straight away build your walls, your wall frames, and they can basically work out how much timber would go in there and what the percentage figure is. And so if you were to use that in your calculations then and include a certificate like that in your consent application, that could be one way of demonstrating that a lower framing fraction is appropriate.
Great.
Yeah.
Okay. So have we covered all the changes for housing and small buildings?
Yeah, I think these are the main changes. We've obviously also made some editorial changes and clarifications to improve the usability of the documents. Just want to mention one more thing, and that is previously it was a little bit unclear how the areas that, for example, you need to put into your calculation method should be measured. And so we've clarified that now. It makes a difference whether you measure, say, a wall on the outside or on the inside of a building. And so we've clarified it. So for the net roof area, the thermal envelope area, floor area, and the net wall area, you now need to use overall internal dimensions. So that's dimensions measured on the finished internal space of all the relevant building elements that form part of the thermal envelope, and they include the thickness of any internal partitions. So I'll just show you a little sketch of how that actually works. On the left, you see that floor plan, and you see the basically the area is measured between the internal surfaces of the external walls. So that's the walls that form the thermal envelope. You also have some internal walls, and the thickness of those is basically just included in those dimensions. That's why it's called overall internal dimensions. And the same in the elevation. So if you look at the height of the building, so you have the ceiling forming the thermal envelope because that's where the insulation is. You've got the floor. You measure between the plasterboard of the ceiling and the top of the floor, and you also include the thickness of that intermediate floor in that dimension. Yeah, so that should be relatively clear, I hope.
Nice thick walls too, like those. So thank you for that. It's quite a comprehensive explanation of the changes for small buildings and housing. Let's talk about the changes for the insulation in large buildings and well, which are other than housing. Can you tell us a bit more about those, please?
Yeah, so again, that's H1 AS2 and H1 VM2 that we're talking about. So these are the documents for buildings that are not housing. So buildings that are not housing and that are greater than 300 square meters. And so we wanted to keep a lot of consistency between the various documents. So a lot of the changes for those large building documents are quite similar or even identical to what I've just talked about for housing and small buildings. So again, the schedule method's been removed. The same exemption where you have heated elements in bathrooms, so like underfloor heating in bathrooms, been added. The option of being able to divide a building into multiple thermal envelopes has been included. So for these documents, you obviously wouldn't have housing, but you still might have different classified uses within a building. And you can basically divide it according to that. We've made updates to the modeling method. You find all the details in the documents. Thermal bridging from frank walls. The same principle of minimum default wall framing fraction of 38%, unless you can demonstrate in more detail that your building has a lower wall framing fraction, and use overall internal dimensions when you determine the areas of your building. The other key change that we've made to these documents is that in H1 AS2, there is the calculation method for large buildings that previously has been quite different to the calculation method for housing and small buildings. We've made some changes there to allow greater flexibility. Previously, you could only play around with the R values of your walls and windows. Now the equations have been changed so that there's flexibility for how much insulation you put into all elements that make up the thermal envelope of a large buildings. And there are, just like for housing and small buildings, there are online tools available that implement the large building calculation method as well.
Wow. Okay. So the overall level of energy efficiency hasn't changed. We're just redistributing minimums, basically, much like the smaller buildings. So thanks for talking us through all those changes. When are these changes happening? When do they affect us?
Yeah, so great question. So these documents have already been published on the 27th of November and can be used now for building consent applications. We're in the middle of a transition period where you still have the choice of whether you want to still use the old documents or already start adopting the new documents. That transition period will finish on the 26th of November this year. And so from after that date, it's only the new documents that you can use for an alternative solution for demonstrating compliance. So get on board, familiarize yourself with these new documents, because 26th of November seems like ages away, but it'll come.
It always creeps up, doesn't it? It's like when you say something, yes to something that the kids are doing, and then you never really consider that's going to happen, and then it happens, and you go, oh, I've got to do that. Right, hey, thanks so much for that. Everyone remember 26th of November 26. I would start moving towards it now, just to make sure it's a bit of a smooth transition for you. Now we do have about 8 minutes for questions, and we have had a lot of questions coming in. First of all, there was we previously had an issue with the large building acceptable solutions. So when people would do something like a warehouse, and then they had a small office in that warehouse, that affected the whole building. How has that been resolved this time, Christian?
So we had a lot of inquiries about that, where previously, if you had a large industrial warehouse with a small 20 square meter office included, the office was the only heated or cooled part of that large building. But because the entire building was so large, it got pushed into the H1 AS2, H1 VM2 large building documents, and that did make compliance much more difficult than what was intended. And so we've now clarified that when you determine the area of the building, like are you greater than 300 square meters or not, that you can exclude certain parts of the building, including those with the classified use of an industrial building. And so in that example, where you have a large warehouse, that would be the warehouse part would be classified as industrial. The office would be classified as commercial. When you work out for the purpose of H1, you work out the area of that building. You would basically exclude the industrial warehouse part and then count only the, say, 20 square meter or whatever it might be, office part. And if that office part is less than 300 square meters, then you can use H1, AS1, or VM1, which should be a lot easier than it was previously.
Great. Okay, lots of questions here. Sorry, I was just reading through some of them. Can you just quickly touch on alterations? So we've got a building consent we've got a house, we're doing a large alteration, we get a building consent. It's an old house. How do we incorporate, or what do we do with regard to H1? Do we use the schedule method? With no schedule method, how do we get around that?
So that's a good question again. So alterations obviously come in many different shapes and sizes, and it's hard for me to now give you a specific tailored answer to whatever your situation is. But we do have a web page. Now I skipped over that slide accidentally, so it's good that it's there. We have a web page if you go to building.govt.nz, so that's our building performance website, and then there's a search box on the top right. You see it here. If you then search for H1 alterations, it should come up with this web page that you see a screenshot of here, and that provides you with information on how you can demonstrate compliance with H1 for alterations and additions. It's not the H1 AS1 or the H1 acceptable solution verification methods have predominantly been written for new buildings. Alterations, it's a little bit more bespoke, and so refer to that web page for some guidance.
Great, thank you. There's a few questions I'll just touch on around multi-unit dwellings. Firstly, there's one from Nigel. With multiple thermal envelopes, is the garage treated as exterior? If not, how is it to be calculated?
So the H1 documents don't recommend that you exclude the garage from the thermal envelope. It's not a mandatory requirement, but it is highly recommended. If you were to include the garage in the thermal envelope, then you would basically insulate the garage as well. You would insulate around the garage. You would need to make sure that your garage door is draft proof and insulated, and the insulation properties of that garage door, as well as the garage walls and the rest of the house, would all need to be known and go into the calculation method equations. There are some default values. So if you don't know what the R value of your garage door is, you can use a default value, and that's specified in H1 AS1. But the recommended way would be to insulate between the garage and the rest of the house, because let's be honest, people don't heat their garage. They heat their living room, their bedrooms, and they don't want all that heat to leak into the garage. Now, it might make sense to insulate the garage in addition to the walls and floor ceiling, whatever, between the garage and the house. And that is, at some point during the life of that building, it is quite possible that people might want to do an alteration, just speaking alterations, and might want to convert that garage into some other habitable spaces that then get heated or cooled. And especially if we think about the floor, the concrete floor of that garage, if you don't insulate it right away, it ain't gonna be insulated later on. So you want to make sure that obviously you do the moisture proofing of the garage floor. You also do and you insulate, even though you don't have to. But that would be going beyond H1 minimum compliance. That would be more talking about good practice.
Great. I've got a double header of questions here for you. Julie and somebody else. It's about window to wall ratios. Would excluding the intertenancy wall area negatively affect the wall to window percentage? So this is when we're doing multi-unit, whether we count it as one big area or lots of smaller areas. Is that correct?
So that's what I talked about earlier.
Yep.
So yes, the intertenancy walls are definitely excluded from the thermal envelope. So that's not negotiable unless, look, I'm showing you the ground floor here.
Yes.
If you were to exclude the garage here, then obviously that bit of wall here, because there's an unconditioned space on one side and a conditioned space on the other side, then it becomes part of the thermal envelope. Yeah. But if there's conditioned spaces on either side, then the intertenancy wall is not part of the thermal envelope, does not go into the calculation method, and as I said earlier, does not contribute towards your 40% window to wall ratio allowance. So not including the intertenancy wall means for this middle unit, it's a bit that 40% window to wall ratio limit is a lot easier to get to than for the end units where you have more walls to play with.
And just on that 40%, so the 40% window to wall ratio is measured from the insides of your walls and the insides of your ceiling as well. Okay, another quick question was H1 AS1 edition 6, table D1.1.1. We've removed the requirement for thermally improved spaces.
It's not a requirement. That's, yeah, I know. So for anyone who doesn't know what table D111 is, so in H1 AS1, there is an appendix D, which talks about how to determine the R value of windows, doors, and skylights. And so for windows, there is a table that lists R values that you can assume for your windows, depending on the makeup of your windows. So depending on whether they are double glazed or triple glazed, whether you use low E glass or not, whether you use aluminium, UPVC or timber joinery. So based on all these different factors, you can easily look up an R value that you can then use for example, in your calculation or in your modeling method, yeah, without having to go and do more detailed calculations, which you can also do. So in that table, the equivalent, we've made some tweaks to that table. Previously, in the 5th edition of H1, AS1, that was table E111. And there was also a column in there about the spacer. So that is basically at the glass edge, what material is spacer between the panes. So if you have double glazing, it's either a plastic spacer or an aluminium spacer generally. And so there was a distinction between that. Brands have done some further calculations and looked into that and found that the difference between the overall impact of that spacer on the overall R value of a window is relatively small. So that for the purpose of using this table with the default R values, we're no longer differentiating you. So regardless of which spacer you have, all other, you look at all the other components and look up your value. That's not to say that thermal spacers are not a good idea. Also from a condensation management point of view along the glass edge, but for the purpose of looking up that R value, that's no longer something you need to worry about.
And we're going down decimal points when we're looking at the context of the whole building. I'll just get you to put that slide up again of the H1 alteration website. Some people are having a little bit of trouble finding that, but can you also just talk us through, there is a question about in your previous slide about with the ground floor insulated and uninsulated spaces, would we be required to have a thermal break between the slab of the garage and the slab of the house? You could, but you could probably design your way around it. Would that be right, by not insulating your slab? Would that be a correct assumption, Christian?
I think that is, again, a great question. And that's, again, where we need to differentiate between minimum compliance and good practice. So to just meet the bare minimum requirement, you don't need to put a thermal break into your slab. And so just to recap, so on one side, so you have a wall, and that might be the wall between your cold garage and your heated spaces. And so the question is, what do you do in the concrete slab underneath that wall, where you basically, the line where one side of the slab gets heated and the other doesn't. If you don't put a thermal break in there, you can still comply. It's not a requirement to put a thermal break in there, but there is a comment in the H1 documents that recommends putting a thermal break in there. It is technically possible. It's not something that gets commonly done in New Zealand because it's something that is a little bit new and different. It's not as it's not as straightforward for many builders, so it's not commonly done. It's something that I would recommend you explore to do. But it's not something that is required to comply.
Right. Hey, thank you for that. Look, we've had we've gone over a little bit by about 5 minutes. Thank you so much for going through that with us, Christian. Please refer to look at the website and look at our all the documentation that's coming out around the consultation. And of course, there's info@building.govt.nz if you have any further questions as well. But there's quite a lot of resources out there now about this. So thanks for your time, Christian. Thanks, Dave, for organising this and pressing the go button when we need it. And thank you guys all for attending. We've had a really good attendance over the last 2 weeks. And again, sorry for the IT muck up a couple of weeks previous. So we'll see you again soon, everyone.